Hello, everyone. I'm going to get started. Thank you for joining our HashiCorp webinar today, prioritizing the security of your apps and databases. My name is Amanda No. I cover the Northeast SLED region at HashiCorp, and I want to welcome you on behalf of all of your HashiCorp account executives. I'll be going over a few housekeeping items before we kick things off. This session will be recorded and shared post-event. If you have any questions, please leverage the Zoom chat feature. We've left some time at the end of today's presentation to answer questions. Today's presenter will be James, a senior solutions engineer here at HashiCorp. So with that, let's go ahead and get started. Over to you, James.
Hey, thank you so much, Amanda. Appreciate it. Good morning, good afternoon to everyone who's joining us today for this particular presentation on prioritizing security for applications and databases. I wanted to just give you a little bit of background about myself. As Amanda mentioned, I am a solution engineer here at HashiCorp. My role is really to be the technical half of a sales team that evangelizes and gives prospects and customers information about our solutions with respect to all Hashi products. Today, we're primarily going to be discussing Vault and Vault under a specific use case. I've spent many years as a software developer. I've also built systems, I've architected systems, I've managed projects and people. Most recently also did a lot of selling of the ServiceNow solution to federal and DoD customers. So welcome today to this conversation that I'd like to have with you with respect to how Vault and security come together to make your environments much, much more secure. I will be going off of camera for this just so that I can let you focus much more on the presentation. And I'll also be giving you a short demo along the way. All right, so a little bit about what I'd like to cover today. We've kind of gone over a few introductions there and discussing who we are. I'd like to set the context for today's webinar by talking a little bit about HashiCorp's cloud operating model, which is really just a perspective that we have developed over the last decade or so for what we see customers going through as they move into the cloud. This process is by no means a trivial one, and it's one that takes many years to complete, if you can even complete it. But along the way, there are certain things that we've come to notice and to see as being challenges that our prospects, our customers encounter along the way. And we've built a suite of solutions really designed to address those particular challenges as they're encountered on that journey. So we call this approach to solving those challenges the cloud operating model. This particular webinar is titled, prioritizing security for applications and databases. And, I think it's kind of important to make a business case for why you need better security for applications and databases. What is the real driver for that? And then I wanted to talk specifically about a sub-use case within that, which is how would you do one of those mitigations, which is really rotating and updating credentials specifically for databases, and how does HashiCorp help with that, right? What is our solution around that? And then I finally want to close the session with a recap of the key lessons, a small call to action to yourselves, and also take any questions that you might have, comments that you'd like to voice with respect to what you hear today. This recording will be available again after the event is complete, as well as this deck is something that I've actually shared back out to my team, and they will be passing along to those of you who are interested in receiving that. All right, so let's begin. And I like to usually start with this idea of that cloud operating model again that I talked about. And the framework for this is really to see and understand that migration to the cloud is a journey. It cannot be looked at as something that you simply say, you wake up one morning and say, I need to move all my applications into the cloud, and here are the specific things I'm going to do. I'm going to spin up a whole bunch of compute, network, storage, couple of applications in there, install that stuff in there, and I have moved to the cloud. There are a couple of things that just make that untenable. One of those is this is rented infrastructure. So as a friend of mine likes to say, the cloud is just someone else's computer, right? No matter what you think you're doing there, this is not an environment that you're managing and running yourself. So with that comes an agency problem, which is you have a firm belief that that agent, your cloud service provider, or whoever else is managing that infrastructure for you, are going to act and behave in your best interests. And many times they are, but not necessarily always in line with what your governance and audit and regulatory requirements might be. So that really requires that you take additional steps to ensure that certain important aspects of that migration are managed or can be managed by you if that's a choice that you'd like to make. So we have come to see and understand that there are 4 essential elements to sort of a distributed architecture. This particular diagram, is just a visualization, and we tend to like to read it from the bottom going up. So actually, that's why it's labeled D0 going up through D3. And the story goes like this. Imagine you have a requirement on a Sunday night to build a house. You're asked, hey, starting Monday morning, would like you to work with a team to stand up a complete townhome. So that Monday morning, one of the very first things you want to do is to really stand up that foundation. You want to set up the superstructure, the shell of the house, right? Everything that is load bearing, going from the concrete on the ground, going all the way up to holding that roof. This is the main structure on which everything else is going to hang. In the Hashi solution or Hashi cloud operating model, that's typically what we see as the first step in that cloud operating model. Our customers tend to move towards the building of basic things like compute, storage, and networking, typically in a cloud service provider of your choice, whatever the flavor of the day is. It might be an AWS or an Azure, GCP in some cases, and actually for many, many small players, much smaller cloud service providers out there. So that's what that D0 layer is. So we provide a capability of tools, services, software that help make it easier to build that basic infrastructure, to build that foundation in an automated way. You can quickly build and quickly destroy any infrastructure that you have in that cloud service provider. And it is cloud service provider agnostic. So we don't make any assumptions about where you are going to be deploying your infrastructure. We have no guarantee you want to do it in Azure or GCP or in AWS or in some other small place. So using our solution, in this case, Terraform, you're able to put up that foundation, that roof, that superstructure extremely quickly, and also tear it down extremely quickly. And we can talk about it another day, but that tearing down is actually a very, very important aspect of being able to go on this cloud journey. The second step, that you'd encounter that very same afternoon would be, okay, looks like we've got some kind of superstructure in place. Maybe when you put a few doors in there, the question becomes, well, how do you secure it, right? So there's lots of zoning rules about leaving lights on in construction zones and making sure that people can't just wander in and out of your infrastructure. Same thing in the cloud. The moment you stand up a machine, the very next question you're going to ask yourself is, did I set passwords or credentials on all this stuff that is really weak and easy to penetrate? Because you might wake up that morning and find someone is Bitcoin mining, to the extent that Bitcoin mining is useful these days, on that infrastructure. You're going to ask yourself, have I left my storage buckets exposed to the world? Can people start freely using this stuff and I would not even be aware? So we provide the second layer of the solution as well, which is Vault, which we'll talk about today, and that's what's circled, which is a secrets management solution. A piece of software really designed to help you manage and store all the secret or credential information that might be used as part of that credentialing infrastructure. So what this means for that house is Vault is going to put locks into the doors and into the windows and make sure that people can't just walk in and out, and that you have to go see the homeowner in order to get the necessary keys to be able to enter that infrastructure. The next day, that Tuesday, you're now sort of feeling much more confident. You're ready to start deploying. You've got your floors. You want to start deploying those applications in there. So you would use something like a mover to bring in that furniture, to bring in the piano, bring in the chairs, the tables, whatever that infrastructure is. They would be the ones who would move all of those things in there. The parallel here in this particular architecture would be that D3 layer in the green, which is really the applications that you now wanted to run on that infrastructure. So you have a nice secure batch of compute running. You have it secured because you have a nice secrets management solution, making sure that all of that is secured. Now you want to be able to deploy applications at will, or retract those applications at will, or migrate those applications from one cloud service provider to another at will, and in a completely transparent manner. So in the house, that simply means I want to be able to have my chairs and tables in one room, but if I make a choice to move them to another part of the house, I want to be able to do that. And I want to be able to do that freely, quickly, and easily. With respect to our HashiCorp solutions, Nomad is an application orchestrator and scheduler that we provide that is able to do that function for you. It will deploy not just applications that are wrapped in containers or as pods for Kubernetes, or as, they'll also deploy legacy applications. So it'll deploy .NET applications, Java applications, straightforward, executables or shell scripts. If you need those moved somewhere, it'll support that. And it'll also help you move them, or rather what we call drain them from one cloud service provider if you want, and then stand them back up in a different cloud service provider. Because Nomad treats all that as infrastructure that is, all that infrastructure as just one pool of compute, and it can split and use those pools of compute as it feels necessary to ensure that you get the best performance of those applications at any given time. And then finally, so now your house is populated with furniture, you have your doors, you have the structure is ready, windows are there. You finally want to make sure that all the rooms are, one room is accessible to another room, and to you can freely move about from one application to another, move about from one room to another, and that's what Consul helps you do. That's the D3 layer, which connects applications regardless of which cloud service provider they might be running in. Think of it as a way to layer on top of that rented network that the cloud service provider gives you. You can overlay your own logical network that controls how your applications in these different CSP environments can talk to each other. You get your own level of control, right, to be able to manage how that happens. if any of these other aspects are of interest to you, we can certainly have another webinar another time and talk some more about the details of how that happens. For today's purposes, however, we're going to talk strictly about this D1 security layer and specifically around why it makes sense for business applications and databases. All right. So a little bit about why it matters, right? Why do we need better security for applications and databases? So applications and databases don't keep secrets, right? They provide valuable business service, right? They manage your CRM data, they help you coordinate, they store your files, they do all of these things. But along the way, they also log secrets, right? It's not uncommon to find systems that are actually logging passwords and credentials and all sorts of things into those log files that are ending up in a Splunk or some other log aggregation software. They dump them in exception traces. I can't tell you how many times as a developer, I myself have also, just made sure that, were the credentials read from the file system and actually are known to the application, and that might show up in application traces. Running diagnostics on these applications will also leak credentials. And if you're debugging applications, you also have them being exposed through some of those endpoints, sometimes just to allow those debugging endpoints to actually get in and look into that. The other aspect of this is applications usually share secrets. So we don't need to call anybody out, but everybody knows that security teams internally within companies tend to look more at the people and worry about people, and frown upon people sharing passwords, right? That one's been beaten into us pretty severely that this is not something that you should do. But I am very sure many of you can probably, recall a situation where you've set up multiple machines and they all have the same password. And that's so convenient, right? It's not changed. And the reason it isn't changed is it's a coordination problem. Credential updating and rotation requires teams to agree on the action. It requires them to all move forward to actually perform the action on a specific date. And the level of effort that takes probably contributes to the next new shared secret that is going to be applied to all these systems. So you might solve the frequency problem, but you don't necessarily solve the consistency problem. So everyone uses the same password, they just change it to a new shared password much more often. Now, part of the thing no one thinks about is when you do decide to revoke a shared credential or to change it, it changes it in so many systems. Think about just changing, for example, your own user password in Active Directory, right? In your identity provider system. That causes, if you didn't have the synchronization of that password across all those systems, the blast radius for where you have to go and change your password to make it consistent just for you yourself is tremendous, right? So that's another concern. And the shared credentials also increase the risk that you're exposing yourself and your company and your organization to exponentially with the number of shared nodes in that network. So as more and more people share pretty much the same password, that risk just expands, but at an exponential rate. And probably much more than that, depending on how sensitive those particular systems are. So this is sort of the problem and the challenge. So if you sort of boil it down, first of all, there is a high cost, right? This is the challenge. There's a very high cost to getting people to act in the way you'd like them to act, right? This coordination takes time, it takes concentration, and also there's a lot of risk, right? Because of that exponential growth in risk from sharing credentials. If there was to be a breach, all of these things are just heightened through the bad practices. So a lot of this can be hopefully mitigated by, well, take the task off of people's docket. Imagine if you don't have to worry or think about new credential updating or rotation whenever you need to access an application. And make it even smoother by introducing automation. So if you take a task off of people's plate and you fully automate it, that just becomes one more thing that you solve for, and you reduce the cost of performing, of behaving nicely and behaving appropriately within the organization. With respect to risk, it really requires, first of all, much more rigor in credentialing. This might mean, no more password 123, much longer, much more complex passwords if you continue to use passwords. You also can reduce the validity of those credentials. This means the time to live for credentials should be reduced. And you reduce access to resources, whether it's secrets or databases or whatever it is, really through finer grained policy controls. So this would be the way you would mitigate that risk aspect. Now, these are not all the things that you can do, but with respect to Vault and what we'll be talking about today, this is kind of what we target as the mitigations for these particular risks. So a viable solution, I think, could be, for example, and specific to the case we'll be looking at today, a user wants to access a resource. In this case, let's say a database. They should be able to talk to some entity, and we're proposing that be Vault, request a credential. That credential is returned. It's valid for a certain number of days or minutes or seconds if it was an application. And what Vault does is in real time creates a user credential, a user account and credential in that database with specific permissions and returns that to the user. So as long as the user needs access and has requested for 7 days, that credential is active, after which all this evaporates and everything is back to a clean slate. So how does it work? Well, with regard to Vault, the application would like to access the database that you see on the right. So the application's there on the left. And we initially configure Vault with using a privileged set of database credentials. It doesn't have to be the real root user or root password. It can be a root user with, or a user with enough privileges to actually create other users. Or you can even use the root username if that's what you'd like to use. We configure the Vault with what we call a role. And the role describes an endpoint. And that endpoint would basically be able to generate new credentials for a user, for an application, with specific permissions. So in Vault, you'd be able to configure 1, 3, 10, 50 roles if you want, all going against different databases or the same database, each role giving different permissions and access to that resource. Once you've configured that, the applications would be able to access the Vault at a specific endpoint and say, I require, okay, well, first they would actually authenticate themselves and say, I am application XYZ. I would like to present my credentials. This is who I am. Please give me a temporary set of database connection credentials that I can use to access a particular database. And Vault would immediately connect, either rotate credentials, or if it was the root, it could rotate the root credential, but it'll also generate credentials, return those credentials to the application, and then that application can read and write from that database for a limited period of time. And I'll show some of this. I'll be using a MySQL database because it's nice and easy to work with. We support this model of working for MySQL, Cassandra, Mongo, SQL Server, Oracle, Postgres. It's a whole host of databases for which this works, and it all feels the same. So think about that benefit there, right? You can configure the dynamic generation of user credentials, temporary user credentials, for all those databases, and the mechanism by which you configure this is consistent regardless of database brand, right? So it doesn't really matter whether you're doing this for IBM or whether you're doing it for something else. It feels the same for your administrators. They have a very simple way to configure these, and they can configure as many of them as they want within one vault. So if you think about the deployment scenario for multiple applications, what you would see is billing applications might have an endpoint that they can hit that would generate credentials for them for, let's say, one database resource. And based on their needs and their scheduling requirements, they probably want only 72 hours worth of connectivity. But for account management applications for another department, another stakeholder, you might want a slightly longer duration for those 30 days. And that, maybe that's because there are more people there accessing systems, and they're not going to operate and do anything in a few hours. They may need a few days. So they can hit the same vault, different endpoint, but accessing that same database resource. And then yet again, for say an order handling app that needs to access these things over a longer period of time, you might have a longer rotation period. Okay, so what I thought I'd do is give you a short demo, just kind of show you and talk a little bit about this in action. And then you can ask me questions at the Q&A section, which will be coming shortly after. So let me break out of character here and jump into the demo for a little bit. So first thing I'll do is, for those who are uninitiated, I'll just quickly show you a little bit of Vault. So, I talk about Vault being a secrets management solution. People wonder, what on earth does he mean by a secrets management solution? And so I'll quickly give you a 3 or 5 minute primer on the Vault interface. So I'm running an instance of Vault here on my laptop. This instance is actually running as a Docker container. You can run it on bare metal. You can run it in the cloud. We even have a hosted service, which we call HashiCorp Cloud Platform Vault, which you can also subscribe to. We deliver it to you in many different packaging formats for just about every operating system. But it is delivered as a single binary, which makes it very easy to work with, right? So literally, upgrading Vault is, I shut down the Vault, I replace one file, I start the Vault back up, and I'm back in business. So Vault is very flexible, right? It allows applications and people to log in many different ways. You can log in using a simple token. I can supply a username, password. This is through the user interface, right? Most of what I'll be doing will be through the command line, but I'm just trying to give you a sense for what an administrator might experience. Maybe I want to log in with my AD credentials, right? So I just would select that as the method of authentication. For those of you who use Okta and other third-party identity providers, OIDC, which is more like government, maybe even your CAC cards, Radius servers, GitHub credentials, third-party credentials, you can use any number of those. I'm just going to log in very simply with a default mechanism that Vault provides, which is called the token method. So I have a token. The token is actually just root, right? So in this case, I'm able to go in and you can see what we call secrets engines. These are the different ways or different types of secret engines that you can have within Vault. So I'll give you an example here. I'll just show you. There are many different types of secrets Vault can generate and manage for you. Key value, which is just like things like username and a password, certificates, maybe SSH keys and credentials. For those of you who know, most of the ways you get into POSIX or Unix-based systems. Here, your Active Directories, Alibaba Cloud, and AWS, Azure, GCP. If you wanted to set up dynamic credentials for those, you can do that as well. We also have integrations back into our own tools, right? So, today we'll actually be using this engine, which is the databases engine. I'll not configure it through the UI, but I will configure it through a command line. It's much more expressive. And here's a simple example of an out-of-the-box key value store. I can, it's at the point called secret. I'm just going to create a new secret. I'm just going to say, for this demo webinar, I'm going to store username, James. I'm going to add another secret. I'm just going to say password, PWD1, right? So, and I can save that. So at this path, demo webinar, I have saved two secrets, right? One is my password and what my username is. And you have to think very broadly about what a secret is. It could be configuration information for an application to pull. It could be standard credentials. It could be a piece of a log file. It could be some sensitive piece of text. It could be a certificate. It could be just about anything. We see all manner of things being stored in the Vault. The nice thing is, because this engine also has versioning, I can actually store all the previous history of prior secrets actually can get stored and managed by the Vault. So I can always roll back and look at prior secret versions if I need to. So this is a simple example of a key value store. And I can mount additional ones, right? If I wanted to mount the certificate generator, I can do so. I can say that's the path, I enable it. And, so now I have a certificate generator. This is just a default session only secret store and the key value store that I had. So Vault is very flexible in allowing you to have many, many different types of secret engines enabled at any time. All of these are accessed and managed by policies that simply say, if you're going to the path, capabilities for self, what can you do? You can update it. In some cases, you can only read. So the policies control that, and we can go much more complicated. And similarly, Vault allows you to configure more authentication methods. So I showed you some at the front, right? The username, password, LDAP, all those. But there's actually many, many more. Kubernetes authentication, Okta is there. I can use my AWS, Azure, GCP credentials to log into the Vault. I can use certificates to log into the Vault. I can use username, passwords to log into the Vault. And even this list is not complete, because if you had your own special authentication method, you can also configure that. All right, so that's Vault in a nutshell, shown to you from the user interface perspective. But for today's use case, I really wanted to show you how we can dynamically generate some credentials for a MySQL database. So once again, I'm running Vault as a container. And in the same environment, I'm also running a MySQL database instance, okay? It's pretty much got nothing in it, but we'll be using it to create a few things, right? And I'll just kind of show you that here. So I'm going to, so here we go. So I've actually got, I had a database running. So I've only got the vault running, but I'm going to start everything up for you so that you can see it in real time. Okay, so this environment is actually the equivalent of a command line, right? So what I mean by command line, for those who are not fully aware, you know, it's just a terminal, right? Oh, come on, James. Right, so instead of doing the demo in an environment like this, I picked a nice little notebook type environment. You can see over here, it says bash. It's a very nice environment to do the same thing. So I can type the same command and I get the response as if I was there. Okay, so the first thing I'm going to do is, as I work on the command line, I need to kind of I need to know which vault I am talking to. So I'm working on my local machine, which is called localhost, and I'm going to talk to the vault on that particular port. Here's my token I mentioned earlier. And I'm just going to say, vault, don't make a big deal about verifying this token. We're just doing a demo. So please let me in. So I've set up my environment that way. The version of Vault, if you wanted to know, I'm working with Vault 1.11. It's very recent. This is as recent as June. And I can ask the Vault, what's the status of the Vault? And in doing so, it'll tell me the two most important things I want to know is the vault initialized? And it says yes, and it's not sealed. So that means the vault is actually available for service. All right, fantastic. And can I log in as my user? Yes, it says success. It has authenticated me. There's the token I supplied. It's unlimited duration in this demo mode. And these are the policies that it's tied to. There's a policy for the root user, and that's what it's tied to. So I'm going to set up my MySQL database as well. I'm going to use a container. So these are just some variables that I want applied to it. So it's going to have a particular root password, which is not very, very nice and secure. This is, just a couple of variables, okay? And so I'm going to set this up and I'll say, Docker, please create for me this particular instance. And I'll say, start my database. Okay. And hopefully that database has started. And if I come over here, I can see down here at the bottom, something that says running for less than a minute. I have my, my database running. You can see some logging. Everything looks good, nothing red. Everything is nice and green. So it's kind of up and running. And I can verify that. I'm just going to ask it, what version of MySQL are you, right? The rest of this is not really important. It's just to help me make that connection. So if I do that, it says you're running version 8.0.29 of MySQL. Fantastic. Okay, so let's get on to our little demo here. So I'm going to remove any prior database secrets engines that are there, and I'm going to enable a new one. Okay, so in one go, I disabled any other prior ones and I just enabled a new one. So if I come back to the HashiCorp environment here, I'm just going to move away from here, come back, and you'll see that I've now enabled a database secrets engine. I'm going to be configuring a connection as well as a role, or what I call an endpoint, to allow me to actually hit that and actually get some credentials dynamically generated. All right, so the first thing we need is we need to configure it with some credentials that are powerful enough to be able to create new users, okay? So this long, complicated statement here is what does that. And then now I'm going to create a role. I'll call it my role, and I provide a statement, a SQL statement that says, whenever you're accessed and you ask to generate a user, run this SQL statement, create user with a particular name, identified with a particular password, and grant all permissions to that user, right? For how long? No more than 2 minutes. So this is going to help me create a role called my role that can generate a credential that only lasts 2 minutes. Okay, so let's do that. And I've successfully written that. So what would you see on this side, right? So if I come back here to the overview for that, you can see it has one connection and one role setup. So if under connections, you can see what I just set up. And under the roles, I have my role, which is a dynamic role. Okay, that's it. Let's generate a credential. I'm going to generate a credential here, but I'm going to do it in a string that allows me to actually log in the database in the next call and actually create a table, right? So I will hit that, and you can see here it creates a user with a terrible name that lasts there, and this is the user's password. This is dynamically generated, and the clock is already running on that 2 minutes. So I'm going to now say, okay, go ahead and create this table. And I can do a select from that table. There's nothing in the table, so it's just bring back the columns. And there you go. So I've used dynamic credentials to log into the database, create a table, and generate some stuff. So I'm going to generate 3 more user credentials from that role with these 3 statements. And you can see them right here. You can see that's the username. And that's the password. Another user, another password, another user, another password. And if I want to see all the credentials I've created so far, you can see right here, there's 4 of them. One of them is probably coming up on that 2-minute mark, right? And will soon be reaped back. So right now, there are 4 credentials dynamically created that allow you to log into this database and perform any function, because that's how we built the dynamic credential generator for this role. So if I just rerun this statement again, we're actually down to 3. So my original 1 that I generated to go create the table has already gone. And I'll come back to execute this statement again, and you'll see these 3 will have disappeared. Now, one of the things I said was that it's pretty ugly, right? This is a very ugly name. And wouldn't it be nice if there was a way for us to actually, generate this and make it look a little bit better, right? So let me see. So if I ran it again, 2 minutes have passed. Those users have all been cleaned up and don't exist anymore. So those were 2-minute long credentials that were generated, right? So we can customize usernames, generated usernames, using username templates. And the way a template works is you would specify whatever you wanted, a particular format. In my case, I want to have the words DOJ, and maybe it's for Department of Justice, and then a role name, and then the word dynamic, and then a random 6-digit number. Okay, that's my template. You can have any template you want, but I'm doing the demo, and that's my template. So I can now then generate credentials using that as my username template. And you can now see that the username generated contains, it's actually 6 characters, sorry, not 6 numbers, but you can use numbers if you want it. So it'll generate it so that it's a little bit more palatable, maybe because it's something that you and your people want to be able to see. And if I do that same listing again, I see the credential. And finally, I just want to say that this same secrets engine can actually also rotate those root user credentials. And it becomes the vault now that manages that root user credential, right? So why is this useful? Well, root credentials are full power credentials. They allow you to do anything, go into any database table, and drop the database, make modifications of all kind. You may not want anyone to necessarily have that, but you may want to have Vault manage those credentials, and then it generates powerful credentials for people as and when you need them. So we have some customers who actually will allow the vault to manage the root credentials, and they will no longer be known by any person, but rather have a role created that can generate permissions that are root-like. Okay. It's quite sensitive. I'm not going to actually run it, but this is the command. You would rotate the root. I actually don't recommend this. I would probably recommend that you create a single root account. Only one person or maybe one entity gets to know that. And then everyone else that needs root-like access has it dynamically generated for them. And that would be the way you would kind of do things. Okay. And that's it. That's it for the demo. So just sort of quickly wrapping up here, if I might. Key recommendations here are really, think about trying this yourself by enabling, a small core team to start, right? There's not much material here that you need to read and understand to know how to do this. And, we would be happy to help you train the person who's going to train others. Think about proficiency, not perfection. It's not a race to being the best. This is really about getting your hands dirty, working with the vault, getting to know it really, really well. So, poor application and database security is reinforced almost naturally by the challenges that come with actually trying to do things the right way, right? Coordination is a challenge. The nature of these systems is it's tempting to always just have the easiest solution, just given the workloads that we all encounter. But dynamic credentialing is a great way to implement that prioritization of security for these resources. As you've seen, configuration using HashiCorp Vault Enterprise is very quick, and it's extremely scalable. Just to give you a sense, we have some, I've heard of customers who routinely will run Vault clusters that can easily operate at 20,000 transactions a second. And I've heard of cases that go up to 10 million transactions a second. So setting up dynamic credentialing can significantly mitigate those security risks and reduce costs for you all at the same time. So please talk to us, connect with Amanda, connect with myself, consider a free webinar. We run these all the time at hashicorp.com/events, all sorts of topics related to Vault, maybe not this use case, other use cases that might be of interest to you. And we encourage you to ask questions, especially in the next section. So please, I'd like to open up the floor to anyone out there who might have any questions about what they've seen. And we can see if I can answer them.
This is Teresa Wilson. I do have a question about auditing.
Yeah.
So when a user gets, a temporary credential, and let's say it's a high level credential, and you mentioned something, which, is a high risk. If somebody has elevated permissions, they could drop a table, they could drop an entire database. I'm assuming you have a way to go track back to the user, to the individual. I mean, because a lot of those credentials they're cryptic looking, but you should have a way to map back to the token, which would take you back to the user or the AD account or whatever you're using, and create some kind of information to show if you were doing an investigation on activity of a particular user. Even though the keys are rotated, even though, we have all the security mechanisms in place, I'm assuming this would still allow us to paint a picture if we needed to do any kind of an investigation, correct?
You are correct. So Vault has a full, extremely chatty audit logging mechanism and it'll log either to a file, to syslog, to a Unix socket. And typically customers will grab those logs with something like a Splunk or various log aggregators, FluentD, and all of these that can summarize those logs. And they typically are doing, streaming and visualization of those details. These logs do not contain credentials, but what they do contain is every single interaction and transaction that occurred within the vault. So we know who authenticated when, we know what path they accessed, we know what role they called upon to generate which dynamic credential for them. So we would know in conjunction with, we don't know what they did in the database because that's the database log that will provide that, but you can correlate the two to find out what user actually dropped the database and tie that back to what dynamic credential was generated and by which user. So there is a mechanism to actually trace back and figure out who did what.
Okay, so within Splunk, if you ported those logs in, there would have to be a way to match the actions in Vault to whatever was collected in the database audit log. And there would be a way to correlate that between the user that got the Vault credential. Okay.
Yes, there is. It would be that dynamic user credential that was generated, the username, in fact. That username would appear both in the HashiCorp log, as well as the user in the database log that did the dropping. And that's how you would connect the two.
Okay, so I just have one more question, and this is based on how our applications currently connect to our databases. Typically, we have right now, and I'm not saying this is the best way to do it or there's not a better way to do it, but let's say, for example, at the application tier, I have what is called a database standard account. And so I'm assuming that what we could still have is the same account, but then the rotating of the password would take place in Vault. And so that would be transparent to the application. So in your demo, you showed like a short lifespan of maybe 2 minutes. So do you have the capability of setting up an account, and I'm sure you probably do, that it's got an indefinite lifespan, but you still rotate the credential? Because you wouldn't, or is that even something that's practical anymore? Does that use case fit what you do?
Yes, it does. So there is, what I showed you today is called dynamic credentialing, which generates both the new username and the new password. We have what's called static credentialing, which will generate only a new password, but keep the original usernames intact. So that way you're only rotating passwords, you're not necessarily changing what that username is for that standard account. So you can absolutely do that and have a standard account with a rotating database credential password
Okay.
that will be generated for you.
Okay,
request.
thank you.
Thank you. That's great questions.
So building on what Teresa just said, if Vault can change the password in SQL, at the very same time, we need it to change a web config file on another server to match. Is that an extra step that can be added in there, like a workflow or because it has to be changed in one or more places?
Yes. Yes, it is. So the database secrets rotation engine talks directly to databases and handles that generation of credentials or rotating of credentials for a database that you've pointed it at. Remember, I mentioned that you can have multiple secrets engines active at the same time. So those would be also available for a different API or person to actually at the same time trigger those to change a credential somewhere else as well.
Okay,
right?
so it's not necessarily a password on another database engine. It's a text file or an XML file or an XML file
Yes.
on another server.
That is fine too. We offer what is, the same Vault binary can run in what's called an agent mode.
Mm-hmm.
And the Vault agent can be triggered to dynamically generate a new credential and spit it out as, say, a configuration file of, based on a template that you've provided, so that a new updated configuration is provided to some application. We see this a lot, for example, with Kubernetes pods that want secrets injected into the pod at different times, usually at application start, maybe at application destruction or container destruction. So there you can use one single Vault instance to participate in the generation of credentials across many different kinds of systems all at the same time.
Okay, thanks. And is the usage of the agent, is that an additional cost, or is that I can put that on any number of servers?
It is not an additional cost. You can put it on any number of servers. And in fact, it's the very same binary that you can run as by passing it configuration that tells it it's running as an agent rather than as a Vault server. So yeah, hopefully that reduces your impact there.
Okay.
Thank you. Thank you for those questions. Others, please.
Yeah, this is Gennady from New York City. Question is, what about patching? Let's say you want to patch your Vault Enterprise. How long it will take to patch?
That's a good question. So when, I'll make some assumptions here. You're running Vault Enterprise either as a container, or you're running it as a binary on a virtual machine, or even on bare metal. Vault is distributed to you as a single binary file, a single executable. So you would literally go through the process of shutting down the Vault. You would move that file, put in the new updated patch file, or the new binary that you want to move to, start up the Vault again, and your patching is done.
Okay, thank you. High availability is available in your case?
Yes, that is a great question. That is one of the strong parts of Vault Enterprise. So when you run Vault Enterprise, you automatically have entitlements to run what we call a disaster recovery cluster. So that would be a second Vault cluster. It runs in passive mode, which means it's not providing service to users. It is simply acting as a second sink for all the data that is in the active Vault cluster. So that's mode one, if I can call it, right? Which is disaster recovery. You set up a second DR instance cluster. It can be in the same region, in another geography, doesn't really matter, but just it's separate and different from the running primary cluster. There is an additional mode you can run Vault in, which is with an additional pay module called performance replication. This allows you to set up very similarly another cluster. It could be in the same data center, same region, or in a different geography. And you can have full replication across both of them. So they're kept in sync. There is one caveat. There's only local leases for tokens are the only things that are not replicated, but that makes sense because if you have a cluster running in Europe and you have another cluster running in the US, you don't really need to replicate the local lease for a token for a user in Belgium over to the US. They're not accessing the US cluster, right? They're accessing the Belgian one. So that's not an issue. But everything else, configuration of the secrets engines, all the secrets, all that stuff gets replicated back and forth and gives you full availability. I hope that helps.
Thank you.
Thank you so much, James. And thank you everyone for attending. We're right at 3 p.m. Eastern. So we are gonna close it for today. As a follow-up, we will be sending out the contact information for me and for James and for your reps if you have different rep from HashiCorp, as well as the slides and the recording. So feel free to reach out with additional questions and for more information. Thank you again for attending. Bye-bye.
Thank you.